Good morning, everyone. In this live stream, like I mentioned in the title, we'll be continuing to work on my Yabbit animatronic, just like we've done in the past few live streams. Today, we're actually going to be working on some CAD, designing the model and all the parts for the head of the animatronic. In the previous videos, we've worked on this Storts platform. This platform right here. This is going to end up as the neck of the animatronic. So this Storts platform uses 6 different motors to drive 6 linear actuators. And by controlling the length of these linear actuators, so by extending or pulling them in, I have complete control over this top platform. This top platform is where the head is going to mount. So this will create a super expressive animatronic because it'll be able to move its head all about. It'll be able to put it down to be sad, lift it up, sink, sag, slouch. So a lot of different emotion will be able to be portrayed through this neck design. And that's a very good improvement over my original Yabbit design. This design was the first animatronic I ever built. It was the first animatronic I ever built, and it's the, I built it before I had a 3D printer, before I had basically any knowledge in CAD or anything. So this was a lot of just sending it, and it worked out pretty well, but clearly not that well. See how janky it is. So the head in this design was baling wire, so like chain link fence wire, super glued together into a ball shape, which I'm surprised super glue worked at all. And then on the inside, there's a popsicle stick infrastructure that holds servos as well as the mechanics for the animatronic. Now, this head had a lot of motion. It had these 2 servos down here, and each one pulled a string, which bent the ear down. Here, I'll show you a little bit better, just like this. So as these servos bend, it bent the ear down. And that was pretty good for conveying emotion. It's super powerful because you can like put your like you imagine sad eyes, you droop your eyes, you droop your ears, but then suddenly he could snap back to attention, like lift his ears up like that. So that was pretty cool. And then the other motion this animatronic had in its head was this eye blink. So its eyelids could move up and down. And then each of these eyes has an independently driven RGB LED in it. So the whole eye lit up whatever color I want, independently of each other, as well as being able to blink. And that's actually the motion I want to recreate in this new design. I'm going to use the same mechanism of ping pong balls and LEDs, RGB LEDs within them, and an eyelid. However, what I do want to do is in this animatronic, the eyelids only come down from the top. In this new design, I want to have them come down from both sides. So come down from the top and up from the bottom and meet in the middle. And I'm going to drive that using 1 servo. And I'm going to use like a 4-bar linkage type design. A 4-bar linkage in order to drive both eyelids with only one servo. So then, now that we've seen the old design and what we're designing on top of this Storts platform, let's look at the control board we designed in the last video, in the last live stream. So if I come to here, yep. So in the last live stream, we worked on this schematic. and then soldered it up. And let me show you the board we soldered. So Raspberry Pi Pico connects here, which is the main controller for this driver. And then it has a bunch of outputs to servos, as well as outputs to the two RGB LEDs, each one that goes in each eye. But there is a change I want to make. Let me go here. Yep. A change I want to make. In the last video, in the last live stream, I left these two pins for spare servos. What I'd actually rather do, or something I thought of since the last video. 1, 2, 3, 4, 5, 6, 7. Yeah. Something I thought of since the last video is I'd actually rather have lighting control than spare servos. Because this animatronic's going to end up on my dark ride, what I want is to be able to control the lighting of each animatronic separately and in sync with its animation. So by having outputs for lighting directly on the control board, I'll be able to set up 2 lights, each of one color. I'll probably have like a main white light and then a separate key light for emphasis that's a different color. And I'll have those pointed at the animatronics. And that way I can control the lighting in addition to the animation. So as the vehicle's driving around, I'll be able to have... So as the vehicle's driving around, I'll have this method of shining light on each animatronic individually, or shining light, or taking away light to hide the animatronic from the rider. So what I'll do is I will just get rid of the 5 volt. I'll change these to, I guess I just actually need to delete and delete. Oh no. And then instead of those 3 pins for the servo, I only want 2 pins once this KiCad loads. I want 2 pins for the LEDs. I want the driven, let's see, 1 by 2. Really? Here we go. And I want the same thing again. Actually, that's wrong. So what I want to do is I want to have 2 pins for each light, and that way I have the pin that's driven by the microcontroller and then the ground pin, and that completes the circuit, so that I can have lighting for the animatronic. So let me get a screw terminal in here. Screw terminal. And the reason I'm using a 3 wide screw terminal here instead of 2 screw terminals, because what I could do is I could have 2 screw terminals, 2 wide screw terminals, that way each one has a dedicated pin and ground. But actually, if we look at the board we've soldered up, there's not necessarily room here for 2 more 2 wide screw terminals, but there is room for a 3 wide. So what I'll do is I'm going to put a 3 wide and then they'll share a ground. And that should be fine because an LED draws so little current that I'm not worried about saturating the current of these screw terminals at all. In fact, they're rated for like 10 amps, and an LED draws in the milliamps. So it's pretty safe. So I'll put this here, and I'm gonna want the ground going to ground, and then I'll move this line up to here. Lighting terminal. And then the other thing I wanted to mention is the reason I'm using a screw terminal here instead of pin header like I have for all the servos and the other LEDs driven by for the eyes is this lighting isn't necessarily connected to the animatronic. So there's going to be wires coming out of the animatronic to the lighting, which will be placed separately and can be moved around. So I want them to be easily removable and be a little more sturdy in case they get tugged on or jerked on. So instead of using pin header, I'm using these screw terminals. So with that updated, actually the other thing we're going to need here are some resistors, just like I have here. So actually just copy this and paste it twice. One here, and then one here. That goes to there. And the reason you need a resistor is the same reason you always need a resistor with LEDs. You always need a resistor with LEDs because the LEDs will happily take more current than they can handle, and that causes them to explode, usually, which is never good for something you want to work. So you put these resistors in, they drop the voltage and limit the current into the LED so that it works properly. You get that full bright LED, but you don't end up with a blown up LED. So there we go. And that's the only schematic change I wanted to do. And now let's look at the CAD I've been working on for this new head design. I believe it is this one. Yep. So like we've looked at before, here's the Storch platform. And then the head mounts on top of here. You can see I've already put in some screw holes into this design. So if we come back to here, this is the design I've worked on so far. So I have these 6 ridges, basically, these 6 spines that form the main circular shape of the head. Once I build this animatronic, what we'll end up doing is we're going to sew a skin out of some fleece I have that's green and yellow, very alien-like. So I'll sew a skin that goes over this, over these splines, as well as having ears and a nose that comes out here, just like the original animatronic. So just like in the original animatronic, how the design is made of splines, and then there's a skin on top of it. That's just like what I'll do here. I'll have these ears. I'll have ears and I'll have a nose just like this. Oh, this one. But I'm not going to add those as 3D printed parts because those are going to be sewn, made with foam. So each of these splines screws down to this bottom plate, and the ones that go into these ball socket joints where the linear actuators connect, I've added a sunken screw head, so there's plenty of room for the screw head to sink down into this recess and not interfere with the ball in the ball and socket joint. And that screws there. And then this top plate, I haven't added screw holes yet. That might be what we do right now, actually. This top plate holds it together and creates that circular pattern on the top of the head. And then what I want to do next, or here, let me show you the eyelids. The eyelids here, so these are ping pong balls, these 2 balls. They will get glued to these support structures right here, to this top one and this bottom one. And those will hold the eyeballs in place. The LEDs will connect right about here on the bottom. And that's as simple as melting a hole in the ping pong ball and hot gluing the LEDs in. And then the black get painted black. And that's to hold the light in to the ping pong ball. So you can see up close in this original design, It's pretty hard to tell on camera, but these ping pong balls back here, they are painted black to hold that light into the, so it just comes out the front. Ooh, here we go. And then these are the eyelids I'm designing. So there's 2 independent eyelids. They come up and down. And I actually did print this out. Let me find it real quick. Where did I put it? Here it is. I have done a test print of this. And if I show it to you, it's basically, they come and they open up and they close, open up, close, open up, close. So that's how the eyelids are going to work. We're going to add a bar that comes out of the top and the bottom, and that will get connected to the 4-bar linkage that is driven by a servo, just like this. So it opens and closes. Boop, 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 boop. And that gets mounted right in front of the eyes, right here. So what I want to do next is I want to include, or I want to make a center platform in the middle of this head to hold the servo that drives these eyelids. And just like in the original design, I had a center platform. It was created with popsicle sticks instead of anything good, but I did have the design there. Did I do that? Yeah. So just like that, but I want to make it better designed, 3D printed and screwed together instead of hot glued with popsicle sticks. Let's go here. Here we go. So I think that's what we'll work on next. So the way I'm gonna do it is I'm gonna make an offset plane up to here, sketch the center platform that's gonna connect to all 6 of these rungs. Well, let's see. One thing I am a little bit worried about is right here. This is blocking the eyelids from opening all the way, I think. So I kind of want to redesign specifically these 2 struts so that they hold back they come back a little bit. So, let's see, what's the best way to do this? I think if I just do a sketch on this plane, then right here at the end will come up and form like this right angle. So the eyelids can open up further. Why is that? Okay. Yeah. So how far apart were these? Let's see. Let's do like 8mm wide. Then same here, 8mm wide. And then we'll close this off. Yep. Yeah. So then what I'll do is I will hide this part. Can I hide that? There we go. And then I'll do another revolve right through here. And then we want to revolve around this axis. We don't want a full, we want one direction. I made it 18 degrees, I think. Nope. 15 degrees. Then opposite direction. There we go. Now, is that what we want? Kind of, not really. Let's see. How could we do this better? Well, first let me figure out... Here, let's look here. So it is 15 degrees wide. But I'm not really super liking this design. Let me come back into the sketch. And what I realized I did is I didn't include any dimensions. So from here to here, let's call this 55. And then from here to here, we'll do like 30. Yeah, there we go. So this gives a little bit of clearance for the eyelids and some of that eyelid fabric to bunch up in this system, in this little gap. But it still allows the overall shape of the head to maintain its structure, as well as, but still providing clearance. And then last thing I want to do is add a few fillets, just so it's all a little bit prettier. Right there, right there, right there, and right there. And this is way mad because it's so wide. I clicked on the wrong line there. There, and not there. And then I might as well make it just a little bit bigger. There we go. So that's looking nice now. We'll have to add this screw hole back in, but I'm okay with that. Oops. Yeah, let's add the screw hole back, and then we'll make a copy of it over to this side. So if I come in here, do sketch, sketch, use this hole, okay. Then we extrude that up and remove, merge part 17, yep, okay. Then the last thing to do is see how this is sticking up? In real life, that geometry isn't gonna work. So what I'm gonna do is I'm gonna use a Boolean function. I'm gonna do a subtract from here. Oh, I want the tool to be this and the target to be this. And keep tools. Oops, keep tools. And what that does is it creates the boundary surface between the ball, between the ping pong ball and this strut is created by this subtraction. So it's like a perfect mesh, and it's able to grab the ball and hold it in. So we'll keep that. And I did say keep tools, didn't I? Guess not. Oops. Edit, keep tools. There we go. So that's looking a lot better to me. And then what I'll do is I will hide this part as well. And then I will do a mirror. Where is the mirror? There it is. So I want to mirror this object across, is it the, yeah, this plane. There we go. So then that shows up exactly where we want it. So now we have that little bit of gap to safely, for the eyelids to open up all the way. So that's looking good to me. And then I will hide this again so we don't have to look at it. So like I said, the next step is going to be a central platform to mount the servo, as well as to add a little more structural rigidity to this whole structure. Now one thing I want is I want this central platform to end up with the servo being basically in line with these, with the pivot point of the eyelids, as well as I would like the servo, or I would like the central platform to have these pivot points for these eyelids built in. So here's what we'll do. We're going to create an offset plane, offset plane, and feels a little bad, but I think I'm just going to make up some numbers here just to get a start. And then, there we go. We're going to do a sketch. We're going to look at it. We're going to hide this part so we can actually see what we're doing. Then we're going to use all of these features as part of our design here. Yep. Ooh. Okay, and then I'm going to basically hide everything, so we're just looking at the sketch. I'll keep these. So what I basically want is I want a big center platform in here. Let me go through all of these and make them construction lines. Construction lines, and then we'll grab this part from the top again. Where did it go? And I want this to reference the center. So I pull that away and make this a construction line again. So now I know where the center of the head is on this platform. So what I will do is I will say we want a center platform, that's a circle, and let's make it in the 70 millimeter zone. And then there'll be these points that come out and connect to the servos. Ooh, I made an arc. Okay, there we go. Then we'll do a line. Let's do it more like this. So we'll do a line here, and then a line here, and then I want these to be about 2 millimeters. 2 millimeters. So what I'm basically saying here is I want this center platform to push into these struts by 2 millimeters, so it creates a very good alignment, so I can screw it all together. And I'll just create a line down the center. And I will make a pattern here that has all of these, and it auto-magically grabs the center. And then one thing I don't like about Onshape is it's a nightmare to do these sketch patterns. But there we go. There we go. Let's just look at what this looks like now with everything re-enabled. Don't want that one or that one. Let's see, I want that, I want that, I want that. Oops. Boom, not that one. Whoa, I was way off. Okay, I see the issue. So when I used these lines, it projected all the way up from here, and I clearly misjudged that. So we can come back to the sketch and fix that up. Then we'll come back to the sketch, edit that, make that normal. Delete that and delete that. And then I want to actually just make this line more like a 0, a 0. So this might be more what we're looking for. If we bring on one of these back, you can see it's just, let's look at more like one of these. So you see the sketch kind of like perfectly matches that. And if I extrude it, let me just extrude this up, then we can do like a, or a remove, and let's do it in the opposite direction. If we make it like 10 millimeter thick, you can see it does interface here decently. And what I mean by that is that it connects, and then I'll have a screw coming from the outside here into this center platform, holding it down. So that could be good. But what I do want to do is I want to come back to this sketch and add some fillets to make this all a little bit stronger, because I don't like how skinny this joint will be once we extrude it. So I'll add some, or we'll add the fillets later. Yeah. So if we bring everything back like this, not that one. There we go. Okay. What I'm noticing here is on these ones that go towards these front legs we just modified, it's pushing in too far. When I extrude this, it's actually going to cut that in half. And I added these reference markers already in the, I already added these reference markers in the sketch for how far it should go, but I clearly went a little bit too far. So we'll come to the sketch one more time, and I'm just going to add a line basically right between these points, like this. So now these two legs will be a little bit shorter than the other ones, which will create a reference point so it's easier to assemble. And additionally, it will create a, it won't interfere with the geometry over here. So let's go ahead and extrude this. Grab these last two legs over here. And I want it to be 10 millimeter thick. $10mm thick looks pretty good to me. And that did create a new object, yep. And then let's add some fillets to all these corners, just for a little bit of added strength, because those hard edges tend to break when you 3D print stuff. There we go. 8. Might as well make them really big since we have the room to spare. I'll go crazy. Let's go 18. There we go. So now that's looking pretty cool. Next thing I want to do is I want to design in the parts that, some features into this part here in the center that will mount these eyelids. These eyelids here. Oops. So, the best way to do this. I'm thinking the best way to do this is probably, well, let's start with the center. The center's a little tough because what I want to do is right in here, I'm going to add some arms that stick out basically from here on top and here on bottom that will control, that will connect to the control rods of the, that connect to the servo that open and close the eyes. But the issue with that is I don't want it to interfere with the platform, with the supports I'm adding in right now. So I'm almost looking at this and wondering if somehow I could make a support off of these two. Off of these two struts here that hold the eye, they could also hold the eyelids. That might be a thing. That might be nicer than trying to mount it off of this main platform. But I also kind of like the idea more of having this main platform that holds the eyelids as well as the that holds the eyelids and the servo all in one. So every time it has to come apart, it doesn't require any fancy, it doesn't require breaking anything or fixing anything or taking anything apart of the actual mechanical linkages, because that would create a lot more work that would be required. So I'm thinking what I'm going to do is I will, what's the best way to do this? Let's put, yeah, I think the best way to do this is going to be to, it's a tough problem. Maybe it'll be best to start with these outer rings. These outer supports might be a little bit easier to design because I don't have to worry about the control features here in the middle. Well, actually, let's look at something real quick. How wobbly? Let's actually try something here. So I have basically the exact eyelid design here printed out already, like this. I'm wondering if we can get away with no middle support and just have these outer supports, and if it'll be sturdy enough. So what I think I'll do is I'll get some flush cuts. Where would those be? Yeah, so what I'll do is I'll get some flush cuts and cut off the central support of these eyeballs. And we can see how well it works. And that way, if it works well enough, I won't need to have any center support, and that'll clear up a lot of space in order to have those control arms from the servo. But if it doesn't work, then we'll just have to design around it, which is completely fine as well. But where did I put my flush cuts is the next question. I've been cleaning up my office recently, and cleaning up means you put things where they belong, but not where you think they are. So that's probably something I need to work on personally, is having a better plan for my office, for my workshop. But here we are. I found my flesh cuts. There they are. So I'm gonna just cut off these center supports, just like this. That's one off. That's two off. And I'm doing this to see if I can get away with not having them. Let's see. So they are pretty flimsy. Well, this one's actually a lot better. Let's see. So I cut off the center supports to see if they're really necessary. And I am noticing that it does flex quite a bit. But I wonder if I can just thicken up this bridge here in the center. Yeah, I'm thinking I'll just be able to thicken up the bridge here in the center. And that should prevent a lot of this wobbling. Especially if these are constrained from the outside. Because what's happening is when they bend, they press out the outside here. So you see when this is bending, that presses out and that presses out. So if these are constrained as well, they don't bend nearly as much. That does add friction though, which might be a concern. But I think this will be okay, really. Yeah, I think we'll go on that design. So let's go back to CAD. Screen share. Yep. And then we'll remove these center constraints. Then another thing I want to consider, since, how do I say this? Because I'm getting rid of this center point, I should actually be able to bring these like nose bridge pieces in deeper, and that way it'll be easier to create a it'll be easier to create this piece on the animatronic. So I'm gonna come back here. Right here between the eyes, with the bridge out so far, this would be hard to create on the current design of the eyelids. But with this new design, it'll actually be pretty easy. If I bring the bridge in, there's more room for this piece in between the eyes, which should be pretty important. So I'll come back to here. And let's work on these eyes. So what I want to do is get rid of these pivot points, bring this eye bridge back a little further, and then make it a lot thicker too. So let's go back. I don't want revolve 11, and it's broken. Okay. Yeah, let's get rid of this and this. Then let's get rid of edit this and remove. Ooh. There we go. Okay. So I've kept that side, but I removed this side over here. Now let's do the same for the lower eyelids. And just remove that. Okay, I'm okay with that. Yeah. Oh, I see. So let's unselect that and unselect that. There we go. Okay. Now we're gonna come back to here. Oh boy, I made this extra ugly. But I think all we really have to do is just kind of delete a lot of stuff. Do from here to here, and let's make it 6 millimeters thick. And then we change this revolve. So, oh boy. Don't want it to include that. We do want it to include these. Not this one. Not that one. Okay. And it's broken still. Why is this? Oh, because we don't want to include that. There we go. There we go. That worked better than I thought it would, to be honest. One thing I noticed is I missed these little slivers. But that's okay. There we go. Fix that. Now that's looking pretty good. We've removed that center piece and brought the nose piece, the bridge, all the way back towards the center. Now let's do the same thing for the lower eyelids. Ooh, it's way broken. Okay. I almost think what I'll be able to do here is delete all these old references and then just basically grab the whole profile. Why are you there? The whole profile of the lower of the upper eyelids and basically just copy it exactly, because we're not too worried about interference on the front edge anymore. Let's see. Bam. Okay, let me just then grab this whole profile. And then, oh yeah, there we go. That's nice already. Cool. So what I did see here as well is because these are revolved parts and the center here got really close to the pivot point, it's basically infinitely thin right here because it's right at the pivot point. So what I'll do is I'm just going to extrude these a little bit so they're a little bit thicker. And then actually let me do a chamfer here and here. There we go. Just add a little more strength right there in those parts. So yeah, that's incredibly thin right here, so that's going to cause a lot of issues. So what I'm going to do is I'm just going to add a little bit of thickness just throughout the part. Ooh, boy. Not what I expected. So if I do sketch right here on this plane, then I'm basically just going to grab like from here and from here. Then I'll just grab this and I'll pull it out. I really don't need it that thick. I just want it a little bit thicker than it is. I'll do like 3 millimeter. That's okay. And then I'll add a chamfer as well, just for a little more strength. There we go. So now that's extra thick in the nose piece. And I'll do the same thing here on the bottom. Normal. Do this. Grab the line. Pop. And then same thing on this side. Pop. Then extrude that 3 millimeters. And a chamfer right here. Cool. So now we have that extra thick nose piece. The pivot's on the outside. Yeah. Then on these chamfers here, I noticed they were pretty weak. So I kind of want to make these bigger, like 5 millimeters. Or even 6 millimeters. Because this adds a little more structure where it's needed right here. Just to prevent any bending right along that axis. And I'll do the same thing for the upper eyelids. Let me see if I can find this chamfer. Edit and make it like a 6 millimeter. Ooh, that's actually going to interfere, isn't it? Let's do like a 3 mil. No, I guess 2 mil it is. Okay, that's fine. Then what is this? Let's go back to this revolve. And we don't want that piece. And we don't want that piece. Oh boy. That's awesome. Okay, I guess we just keep that piece and deal with it later. Okay. Thank you, Onshape. Cool. So now let's come in and design the pivot points that come out to the outside here. Now, I think we could have this mount one of two ways. One way is we design the center platform such that the mounts are always right here and right here, and you have to bend the eyelids into place in order to make it snap in. And I don't see any problem necessarily with getting it to work with the bending, because these eyelids are super bendy, so I can just flex them. Here, I can flex them inwards enough that I should be able to snap them on like that. But I don't super love that because I'd have to do both at the same time and bend them in like this. Let me show you. Like this, I'd have to bend them in order to snap them on. That's not great. So what I'd rather do, I can have one side permanently mounted and one side screwed in. That might be a little bit nicer for design wise. Or the other option I'm thinking is, no, I don't think that'll work. Yeah. So we'll have a piece come off like here on the platform, come out to here, and then curve up and create a pivot point for this bad boy right here. And an equivalent piece on this side. Yeah. Yeah. So I'll have a piece come out here, come up and into the eye holes or the pivot points. Yeah. Into the pivot points on each side. Yeah. So let's design that, and then, yeah, let's design at least one of these real quick. So if I do sketch, come down to here, do the other normal, and then grab this geometry and hide this piece. So what I want is I want a piece that comes out like this, out from here, and then up. So let's start with the simplest possible design, which is going to be a rectangle grid. And then I'm going to add some clearance of 0.6. And I want this to be 8, let's do 5mm thick. Then I basically need this line to be a construction line. Yep. Yeah. Okay. And then the simplest possible way to connect this is going to be just 2 lines like this. Might as well make them parallel. How do we feel about that? It's not my favorite thing. I think it would actually be better to have these lines go from here over to like this point. Let's see. Let's do a line to here, and then a line to here. Let's have these be parallel, and then these be 10 mil apart. Ooh, 10 mil apart, 10mm apart. So now what this is essentially add flip direction 10mm. So now this leg comes out and we'll extend it up to here, with a little joint that sticks out. Yeah. I don't super love how thin and wiggly this looks. And it also, here, this part is like a perfect circle around it. You see it sticks out pretty far, which I don't love. But it will give him more structure in the face, you could say. I've just been on the wrong. Yeah. All right, here's what we'll do. I'll keep working on this design. And we'll come back to it next Sunday for the next live stream. I hope to see you guys. I'll come back next week. I had a great live stream with you guys this week. And a good time working on this animatronic. In the next video, the next live stream, we'll keep working on this design. And hopefully, I'll actually have it done by then and we can actually assemble it and see how well it all works. So thank you guys for joining. I'll see you guys next week.